Hi, welcome to the ComSci 137 lecture. Sunny here. The module will discuss the TCP/IP protocol suite. Let's start. Penny and Amy are friends who live far away from each other. For fun, they each bought a toy robot which listens and transcribes the words into text. The robot can also read a letter and say it aloud. They agreed to use their robots to write their messages to each other and send it via mail. To add some privacy, they adopted an encryption technique. So Penny will talk, and the robot will listen, and the robot will make a plain text. To add some privacy, she will encrypt it to make a ciphertext. Then she will send the mail. The mailman, in this case, uses a truck. When the truck arrives at Amy's to receive the mail, she will receive the ciphertext, so she needed to decrypt it. The plain text will be read by the robot and say it aloud while Amy listens. In response, Amy will talk and the robot will transcribe it. For privacy again, they will encrypt it, and now she will send the mail. At Penny's part, she will receive the mail and decrypt the ciphertext, and the robot will read the mail and she will listen. Protocol layering enables us to divide a complex task into several smaller and simpler tasks. It has two principles. The first principle dictates that if we want bidirectional communication, we need to make each layer so that it is able to perform two opposite tasks, one in each direction. For example, the first layer tasks are talk and listen. The second layer, it is encrypt and decrypt. The third layer, it is send and receive. The second principle that we need to follow in protocol layering is that the two objects under each layer at both sides should be identical. For example, the object under layer 1 is a plain text. Under layer 2, it's a ciphertext. Under layer 3, it's a mail. An advantage of protocol layering is modularity. Each layer is independent and only concerns the input and output. For example, if the encryption key is known, only the layer for encryption should be changed. The process will still work. Or if the mode of delivery is changed, the letter can still be sent and received. The TCP/IP protocol suite is a hierarchical protocol made up of interactive modules. The upper-level protocol is supported by one or more lower-level protocols. It is also called the Internet Protocol Suite. The original TCP/IP protocol suite was defined as 4 software layers built upon the hardware. Today, TCP/IP is thought of as a 5-layer model. Layer 1 is the physical layer. Layer 2 is the data link layer. Layer 3 is the network layer. Layer 4 is a transport layer. Layer 5 is the application layer. Let us assume that the computer A communicates with computer B. As the figure shows, we have 5 communicating devices in this communication. The source host, the link layer switch in link 1, the router, the link layer switch in link 2, and the destination host. Each device is involved with a set of layers, depending on the role of the device in the internet. The two hosts are involved in all 5 layers. The source host needs to create a message in the application layer and send it down the layers so that it is physically sent to the destination host. The destination host needs to receive the communication at the physical layer, then deliver it to the other layers to the application layer. The router is involved in only 3 layers. There is no transport or application layer in the router. The second principle of the protocol layering is shown here. For the physical layer, objects are called bits. In the data link layer, the objects are called frames. In the network layer, the objects are called datagrams. In the transport layer, depending on the protocol, it's either called segments or user datagrams. In the application layer, the objects are called messages. The physical layer identifies the characteristics of the hardware to be used for the network. It is responsible for carrying individual bits in a frame across the link. Communication is still logical, but there is a hidden layer underneath which carries the electrical or optical signals. The data link layer identifies the network protocol type of the packet. TCP/IP, however, does not define any specific protocol for data link layer. It supports all the standard and proprietary protocols. The network layer is responsible for host-to-host communication and routing the packets through possible routes. The main protocol here is the Internet Protocol or IP. IP defines the format of the packet. Also defines the format and structure of the addresses used in this layer. However, it's a connectionless protocol that provides no flow control, no error control, and no congestion control services. However, there are several support protocols, like the Internet Control Message Protocol or ICMP. It helps IP to report some problems when routing a packet. Another is the Internet Group Management Protocol or IGMP. It helps IP in multitasking. The Dynamic Host Configuration Protocol or DHCP helps IP to get network layer address for a host. The Address Resolution Protocol or ARP helps IP find the link layer address of a host or router when its network layer address is given. The Transport layer is responsible for giving services to the application layer. The main protocol is the Transmission Control Protocol or TCP. It is a connection-oriented protocol that first established a logical connection between transport layers at two hosts before transferring data. It has flow control, error control, and congestion control. Another protocol is the User Datagram Protocol or UDP. It is a connectionless protocol that transmits user datagrams without first creating a logical connection. It only adds port addresses, checksum error control, and link information. Another is the Stream Control Transmission Protocol or SCTP. Its feature has the best of TCP and UDP. It is designed to respond to new applications that are emerging in the multimedia. Process-to-process communication is the duty of the application layer. The application layer in the Internet includes many predefined protocols, but a user can also create a pair of processes to be run at the two hosts. The Hypertext Transfer Protocol or HTTP is the vehicle for accessing the World Wide Web. The Simple Mail Transfer Protocol or SMTP is the main protocol used in electronic mail services. The File Transfer Protocol or FTP can be used for transferring files from one host to another. The Terminal Network or Telnet or in Secure Shell or SSH is used for accessing remote sites. The Simple Network Management Protocol or SNMP are used by an administrator to manage the Internet at global and local levels. Two of the important concepts in protocol layering is encapsulation and decapsulation. At the application layer, the data to be exchanged is called a message. When it goes down the transport layer, a header will be attached to it. It will now be referred as a segment. The segment goes down the network layer. The network layer will add another header, and it will now be called a datagram. When the datagram goes down the data link layer will add the head and the tail. It will now be called a frame. The frame will be converted to bits once it goes down the physical layer. When it arrives at the next node, the process will be reversed. When the bits of the physical layer goes up the data link layer, it will be viewed as a frame. At the data link layer, the head and tail will be analyzed and discarded as it goes up the network layer. And the process goes on. Since the TCP/IP protocol suite uses several protocols at some layer, we can say that we have multiplexing at the source and multiplexing at the destination. Multiplexing in this case means that a protocol at a layer can encapsulate a packet from several next higher layer protocols. The multiplexing means that a protocol can decapsulate and deliver a packet to several next higher layer protocols. Another concept in protocol layering is addressing. As shown before, we have logical connections between pairs of layers in this model. Any communication that involves two parties needs two addresses, the source address and the destination address. The link layer address is also called the physical address or a MAC address. It is the lowest level address defined by a node's LAN or WAN. Its size and format varies depending on the network. For example, the Ethernet uses a 6-byte physical address written as a 12 hexadecimal digits separated by a colon. The first 6 hexadecimal digits is actually called the OUI, or the Organizationally Unique Identifier. This example, the sender with an address of 10 will send a message to the receiver with an address of 87. All connected devices on the LAN will receive the message. When they check the destination address and it does not match, the packet will be dropped. Only the correct destination will accept the packet. The logical address is necessary for universal communications. It is actually known as an IP address. It is 32 bits. There is no two publicly addressed and visible hosts on the internet that can have the same logical address. This example, physical addresses are numbers, while logical addresses are letters. Sender with a logical address of A sends the message to the receiver with a logical address of B. See here that the physical addresses changes between LANs, but the logical addresses stays the same. The objective of internet communication is a process communicating with another process running on a remote computer. Port numbers, which are 16-bit numbers, used by processes as addresses. Here, process A sends a message to process J. Names or specific names are used in the application layer as user-friendly addresses. Examples are email addresses and URLs. I used the Wireshark application to capture the packets. Let us now examine the packet. At the application layer, it contains an HTTP packet. The highlighted blue part at the lower left is the actual content of the packet. The lower right is the interpretation of the application to that content. At the transport layer, the header attached consists of the port numbers. At the network layer, the header added contains the IP addresses. At the data link layer, the physical addresses are added. This concludes Module 3. Thank you.